Did you guys get a chance to look at the video I left for you for the last lesson? Yes. If you haven't yet, you'll definitely want to look through that. I guess I can. Let's go and do that. I'll drop those notes in from the other class. Oops, that's what I meant to do. Paste. And this would have been, what was yesterday or Monday, Tuesday. All right. You guys want to start with questions from homeworks at this point? So we should have, at this stage of the game, everything from chapter 8 that you guys are responsible for has been assigned. Do we have questions from chapter 8 on homeworks? Yeah, Nicole. 52. Sure thing. Let me just pull that up here. Okay. So this says find a possible vector line equation in the IB component form. Okay. For the following lines given the slope-intercept form. So remember that our vector equation for a line looks like this. So to do this, we need, goodness, I hate this. I need two vectors. I need a point vector and a slope vector. So my point vector can be any point on the line in question. What I usually use is the y-intercept, because I can read it right from the point slope equation for the line. The y-intercept for this line is 0, -7. So I'm just going to use the point vector 0, -7. My slope vector will just be the slope for this line. The slope for this line is 2/3. Now remember, slope is change in y over change in x, right? So the x component for my slope vector needs to be the change in x, so the denominator, and my y component for my slope vector needs to be the change in y, the numerator. But now that I have that, one possible answer would be that. Now, it says all possible because the point vector could be any point on the line. So any point on this line is fine to put there. I don't know why you'd use anything other than y-intercept, but you could. And the slope vector could be any scalar multiple of 3, 2. So if I multiplied it by 5, still works. If I multiply it by -2.6, still works. So that's why it says any or a possible, because there's infinitely many possibilities. Why you would write any one other than this one would be beyond my comprehension, but you could have. It wouldn't have been wrong. But boy, you're making extra work for yourself, and I'm not into that. All right. Nicole, feel good there?
Yeah.
Perfect. Who else? Hi, Sam. Come on in. Morning. Yeah, Tia.
Question after I copy this one.
Okay, what's up?
64.
64, yeah. Let's look at it. So this is going back the opposite direction. So here we're starting with the vector equation for the line. And we're wanting to end up at the slope-intercept equation. So I'm going to start the same way. I know I have my point vector, negative 2, 8, which tells me the point, or the point negative 2, 8 is a point on my line. Everybody's okay there? Okay. And then I have my slope vector, 3, negative 1, which tells me the slope on my line will be change in y over change in x, so negative 1/3. Tia, you feel okay so far? Okay. Josh, what's up? Okay. Now I'm going to take these two together to try to write my y equals mx plus b equation. Now I have my m, right? What I don't have is the b. To get that, I'm going to take that point that I'm given, that's an x and a y. I'll plug it in for the x and the y in that equation to solve for b. And then I'll have everything I need to write my answer. T, are you happy with what we've done so far? The W's were getting me there. Okay. So negative 2 times negative 1/3 is 2/3. And then I'll subtract the 2/3 from both sides. In order to do that, though, I need to make a common denominator. So I'll multiply 8 over 1 by 3 over 3. So I get 22/3 for b. So with that, I can say my equation for the line is y equals 1/3 x plus 22/3. Does that feel okay? Good. So again, it's just like decoding this into an Algebra 1 problem, right? I just have to take that vector equation for the line, decode it into a slope and a point, and then it's like an Algebra 1 problem that we would have done. You got another? Okay. 66. Okay. So it's the exact same thing. So I can tell right away that my point that I'm going to use is 3, 5. You good with that? And the slope is going to be negative 2 over 7. So I'm going to do the same thing. I'm going to then plug this into the slope-intercept equation to solve for b. If I add 6/7 to both sides, I'm going to need a common denominator. That common denominator would be 7, so 5 turns into 35 over 7. So my b is 41 over 7. So y equals negative 2/7 x plus 41 over 7. That feel good? Good. Others? Questions from homeworks? Yeah, Josh.
Number 65.
65. Okay. So again, kind of the same thing. We're going to have, hopefully we can read from the problem that the point is going to be -6, -12. And the slope is going to be -4 over -1. Is everybody cool with how I read that? Now I recognize that -4 over -1 is just 4. So, slope-intercept equation again. Plugging in my m, x, and y to solve for b. I'll add my 24 over. I get 12 for b. So I have y equals 4x plus 12. Josh, that feel okay? Okay. Now, did you guys get down into like 73 through 76? Because that's the kind of question that we're going to ask you to be able to do on the test. Should we do one of those? Okay. So that's the only type of question from section 4 that I'm going to ask you to do on the test. So to do this, what I'm using is kind of this flow chart that I wrote up, or that we did in the notes. So if I'm given two vector equations for the line and I want to determine if they are parallel, intersecting, or coinciding, you could put that on your note card, sure. I first ask, do they have the same slope vector? And then depending if they're yes or no, I do, different things. And that's basic. This is the flow chart that I'm going to use. I'm just showing this to you once. So you're like, when I start doing these problems and you're like, what are these questions? Why are you asking this? What are you doing? This is what I'm referring to. Okay. And in fact, maybe let me grab that guy. Let's just grab it and we'll copy it over real quick so that it's on the same page so we can do it like in parallel. How's that sound? It's probably a good idea, right? All right, let's drop that in. Okay. All right. So let's do, say, let me open that real quick to make sure I have okay. So what we're gonna do, we'll do 74 and we'll do 76 here together. Sound okay to you guys? Okay. All right. So doing 74 first, I'll do that in green. It says, do they have the same slope? So it's basically what I'm doing is I'm checking to see if the two slope vectors are scalar multiples of one another. So I'm going to take the slope vector from the first line. So that's the 1, 7. And see if that's a scalar multiple of the slope vector from the second line, which is 6, 4. So if I scalar multiply 1, 7 with k, that's basically 1k, 7k. I should put it. is that, right? And I know those two vectors are equal if each component is equal. So for these two vectors to be equal, k would have to be 1/6 to make the x component equal, and would have to be 7/4 to make the y component equal. But that's different k's, right? And since those two k's are not the same, we are not parallel. Everybody's okay with what I did there? So we just checked that condition. We got no. So we know that the two lines are intersecting now. Let's just say intersecting here instead. Helps if I can spell things. Okay. Now to find that point of intersection, now that I've determined they're intersecting, because if the lines have different slopes, there's no way they can be parallel, there's no way they can be coinciding. They have to cross at some point, correct? To find that point of intersection, I'm going to take the equation 1 and set it equal to equation 2. So equation 1 was 0, 8 plus 1, 7s, and I'm going to set that equal to 12, negative 3 plus 6, 4 t. Is everybody okay with what I did there? Okay. Next thing I'm going to do is I'm just going to add these vectors, do the scalar multiplication, then add the vectors together. So when I add this side, I'm going to get 0 plus 1s, and then 8 plus 7s. And that's going to equal 12 plus 6t, negative 3 plus 4t. Is everybody okay with how I added those vectors together to get that result? Move that up so you guys can see it. Okay. Basically just straight across, right? All right. I know, again, if these two vectors are equal, their components have to be equal. So those two things have to be equal at the same time. That forms a system of equations with two variables, right? So in Algebra 2, we would have spent like a whole chapter talking about methods to solve a system of two equations. So some of those methods might have been including but not limited to graphing, substitution, and elimination. Did you guys also use a matrix to solve these? That's what I'm going to do because the calculator can do it all for me. So I'm just going to set it up and let the calculator knock it out for me. Because if you remember solving systems, this could get a little bit hairy. 2 variables, not so bad, but like once you get to 3 and 4 variables, it's just kind of like a really messy nightmare. So I'm going to let the calculator do the work for me. In order for me to enter this into my calculator, though, it has to be formatted, the equations have to be formatted a specific way. So the equations have to be formatted so both variables are on one side and then the constants are on the other. And the variables have to line up vertically. So for the first equation, I'm going to subtract the 6t over, and then the 0 doesn't really matter because it's just a 0, right? And then for the second equation, I'm going to subtract the 4t over, and then I'm going to subtract the 8 over, to create that system. Is everybody cool with the way I rearranged that? And you'll notice that everything lines up, right? S's line up vertically, T's line up vertically, equal sign lines up vertically, constant lines up vertically. Has to be formatted like that in order to do this in your calculator, but I'd rather do that than like grind through a substitution or elimination. All right. Calculator time now. If you have your calculator with you and you'd like to take it out and follow along to practice these steps while I'm showing you them again, you're welcome to do so. If you just prefer to sit and listen, that's totally okay also. So I'm going to start by opening my matrix menu. So on my calculator, that's second, and then the x to the negative 1 button right below the second button, right underneath the math button. I'm going to move over to the edit tab, and then I'm going to select any matrix from here. It doesn't matter if there's numbers here or not. We're going to type over anything that might have been there anyway, so no big deal. So I'm going to just pick matrix A. So the matrix that we have has 2 rows because it has 2 equations and has 3 columns, one for the S's, one for the T's, and one for the constant. So we need a 2x3 matrix. So I just type the number 2 and press enter and the number 3 and press enter. Or if it's already there, you can just like scroll past that stuff. And then I'm going to enter in just the coefficients for my system. So I'm going to type 1, -6, and then 12 on the first row. So I press 1, enter, -6, enter, and then 12, enter. And I'll do the same thing for the second row. So I'll do 7, enter, -4, enter. Oops. -4, enter, and then -11, enter. Everybody's okay with how I've entered the matrix into my calculator? Once I've finished that step, I'm going to exit out. So I'm going to press second in the mode button, which will return me to the main screen. And now I'm going to go back to that matrix menu, so second, and then the x to the -1 button. I'm going to move over this time to the Math tab and scroll down until I see the command RREF. Now you have to be careful. You want the one with 2 R's because there's also a REF. We want the RREF. You want the pirate with the stutter. RR. That's supposed to be a joke. Nobody laughed. So I'll select that. And I'm going to do that RREF command on that matrix A that we've just made. So once again, I'm going back to that matrix menu. And this time, I'm going to stay on the Names tab and just select that matrix A that I just made. And I press Enter. So what this reads as, each row represents an equation. This first row represents 1s plus 0t equals -3. So I know that s is -3. The second row says 0s plus 1t is equal to -2.5. So I know t is -2.5. Is everybody okay with that? And I knew which, on my calculator, I knew which column was my S column, which column is my T column, because it's just going to match whether I put S's first or T's first when I wrote my system. For me, I do everything I do, I try to keep it in alphabetical order so it's organized and intuitive to me. But it doesn't matter if you would have written the T's first, you would have still gotten T equals -2.5 and S is 3. Or -3, I should say. Miscopied the negative. All right. Now, this is not your point of intersection. Your point of intersection is not -3, -2.5. To get our actual point of intersection, I'm going to pick one of these two. I'm going to pick the negative s equals -3 because I'd rather not deal with the decimal. And then I'm going to plug this into the equation that had the s in it. So it's going back into the equation here. So I'm plugging into this one. That was the s equation. S has got to go into the s equation. Can't plug s in for t. So when I add these vectors now, I get 0 plus 1 times -3, or -3. And then 8 plus 7 times -3. 8 plus -21 is -13. So my answer should be the point -3, -13. Of course. That feel okay there? Okay. So we'll do now number 76. I'll do that in blue. So it starts the same way. I want to check to see if I have the same slope vector. So I'm going to take the slope vector from equation 1 and see if it's a scalar multiple of the slope vector from equation 2. I've already forgot the numbers. I have to go back and look at... that's not the slope vector though, genius. So I check that. So 8k needs to equal -4, and 2k needs to equal -1. So k should be -4 over 8, and k should be -1 over 2. And I notice that -4 over 8 does reduce down to -1/2. So those are the same slope vector. Everybody's okay with that? So these two lines do have the same slope. So that means they're either parallel or coinciding. To tell the difference between them, what I want to check is to see if the point vector from equation 1 is also a point on equation 2. So what I'm going to do is I'm going to take the point vector from 1 and see if that satisfies equation 2. So everybody okay with what I did there? Could I have done it the opposite way? Could I have taken the point vector from equation 2 and see if it was a point on equation 1? Yeah, sure, of course, no problem. Could I have picked something other than the point vector to use that's still a point on equation 1? Yeah, but it's a lot of extra work to do it that way. I recommend against it, but sure. Doesn't have to be the point vector. It could be any point on equation 1 and see if it's also a point on equation 2. But goodness gracious, don't make extra work for yourself. All right. So what this says is I need to see if 6 equals 2 plus -4t. Or for these two things to be equal, I should say the components for the vectors need to be equal. So 6 needs to equal 2 plus -4t, and 9 has to equal 11 plus -1t. So all I'm going to do now is just solve each of these equations for t and see if I get the same t or a different t. So if I take the first one, I'm going to subtract 2 from both sides. So I get 4 is equal to negative 4t. Divide both sides by negative 4. So I get t is equal to negative 1. For this one, I'll subtract 11 from both sides. So negative 2 is equal to negative 1t. Divide by negative 1. And I get t is equal to 2. They are not the same, which means that any point from equation 1 is not a point on equation 2. So you have two lines that have the same slope, but they have no points in common. That's parallel. If you have two lines with the same slope and they have one point in common, they have to have every point in common. That's the coinciding. So this is telling me then that these two lines are parallel. Okay? So this is the only type of problem that I'm going to ask you to do from section 8.4. Is just this. I'm going to give you two vector equations for a line, and you need to be able to interpret whether they are intersecting, coinciding, or parallel. So if you look at your test description that I put up on the OneNote, so students should be able to convert a vector from, or given by an initial and terminal points, to component form. That's the head minus tail rule, right? Convert a vector in component form to a linear combination form. That's just tacking a plus I onto the x component and a plus, and then the j onto the y component, right? Should be able to add, subtract, and scalar multiply vectors. Okay. Be able to find the magnitude and direction of a vector given in component form. So that's using the magnitude formula, like the square root of the x component squared plus the y component squared. And the direction, we draw that picture similar to what we did way back in first semester, where we draw the standard position angle and solve for the theta. Compute the dot product of two component form vectors. So the dot product is the product of the x components plus the product of the y components. The dot product is just a number, not a vector. Convert a vector given as magnitude and direction to its component form. So to do that, you just do magnitude times cosine of direction, comma, magnitude times sine of direction. That'll take you to component form. Compute the angle between two vectors. So that's that theta equals cosine inverse of like u dot v divided by the absolute value, or the magnitude of u times the magnitude of v, right? There's a formula for that, but it's just a formula. It's a nasty formula because there's a lot to do for it, but compute the projection of two component form vectors. So project from u onto v. Remember, there's a formula for that, right? Like the projection of u onto v is the dot product of u and v divided by the magnitude of v squared times vector v. That result will be a vector. It's essentially a fancy scalar multiplication. And then you'll have an application. So I'm going to give you the choice of two different story problems. You just can pick one to complete. As you saw, I think in section 3, there are basically two types of story problems in there, right? There's like the navigation problems, where you got the boat going, and then you had the ramp problems, where you have like somebody sliding down a hill or being pulled up a hill or something. So that's the test in a nutshell. Does that feel okay? If it's me, things that I would put on my note card, I would put my vector diagram on there. So I would include this because it has all the directions how to convert between these different forms, because that was definitely said was going to be on there. And I would have this flow chart that we just kind of talked about and did an example with, because that's kind of a tricky process to remember unless you've done a bunch of them. I wouldn't want to have to rely on memory. I'd just assume just give me the flow chart, and the directions to do these little tests are easy enough to check these things. But I prefer not to have to rely on memory. So I would definitely want to include those things. If you look at your review packet on the last page, this list of formulas are things that would be provided for you on the test, so you don't need to include those necessarily on your half sheet if you don't want to. You're free to do that. It's your half sheet, you do whatever you want with it. But these things will be on the front page of your test, so you don't have to put them on your half sheet if you don't want to. You can if you want, though. Any questions about what to expect for the test? I think that's pretty specific. Easily the two most difficult questions are going to be the story problem application, and then are these two lines intersecting, parallel, or coinciding? So I think that those are the most in-depth, that require the most amount of steps. It's the easiest kind of problem to get lost in the sauce on. I would recommend for the application problem just picking one or the other type, whichever one you feel the better about, and like include an example about like how you kind of get from the beginning to the end there. And I would definitely want to include an example like what we just did using this flow chart, so that I'm, but that's me. That's what I would worry about. I think that individual vector calculations are usually pretty easy, scalar multiplying and adding vectors and doing dot products and stuff. Like those calculations themselves are just have to follow a formula, understand what I'm looking at when I look at the formula, but the formulas are given to me. I wouldn't want to spend a bunch of my time on that, where it's just like, can I follow this formula direction? Yes, I can. Is the formula given to me? Yes, it is. I got bigger fish to fry on this half sheet than making sure I can add vectors or something. Like, that's a pretty easy thing to do. How do you guys feel? Okay about what to expect? Okay, I'm going to stop talking and let you guys get cranking on your half sheets here. Colbs? Yeah, sure. Josh, you got something too? Okay.